In this short video, I'm going to talk about water surface rendering modes in HEC-RAS and why they matter when you're visualizing your 2D flood model results. HEC-RAS offers three rendering mode options: sloping using cell corners, sloping using cell corners plus face centers, and horizontal. These affect how water surfaces are displayed on your map, but not how the model calculates the results. And the way to get to this window over here is by clicking on this button over here, which allows you to change the rendering mode. The first option, which is also the default mode by HEC-RAS, is sloping water surface elevation. This mode interpolates water surface elevations between cell corners, which gives you a smooth, connected look across the floodplain. As you can see, it is great for visualizing shallow flooding in areas with steep terrain, but you should be careful because this smoothness can sometimes misrepresent how much water is actually in each cell because it's interpolating the water surface elevations, especially if your grid cells are large or the terrain is steep. Okay, so to show you how it's going to look like, I have sloping cell corners selected, and you can see that I have the cell boundaries over here as well. I'm going to create, this is the profile line that I have, and I'm going to show you the water surface elevation right over here to show you how the water is going to look like. There we go. Okay, so I'm going to make this smaller so you can see what's going on. So there is water right over here, as you can see, and you can see the sloping, and there is water right over here. And again, you can clearly see how water surface elevation is sloping right over here as well. Okay, so let me make this minimize. I want to go to the second option or third option over here, but first I wanted you to be able to see the visual difference. When I say the smooth look, when we are choosing the sloping, you can see how smooth water is connected to each other, right? Now I'm going to switch it to horizontal and click apply, and you will see that it is not smooth at all. There are areas that have water and are disconnected, similar to this area right over here as well. So let's talk about the second option, which is the horizontal water surface. Here, each 2D cell is filled to the exact water level that the model computed. No interpolation, just a flat water surface elevation in each cell. This mode is more accurate to the computed results, but it can look more fragmented, if you will, especially in hilly areas or when using very large cells. You might see isolated patches of water instead of continuous flood. So comparing this to the sloping, you can clearly see what patches I'm talking about. This is very smooth. And again, when I apply the horizontal, you can see the patches of water. Okay, so now if you are curious to see how water surface elevation looks like here, first of all, let me bring this right over here so we can compare. I'm going to create the water surface elevation again and bring it down here so we can compare. Okay, so as you can see, the water surface elevation is flat and it cuts suddenly. It cuts actually when the cell phase ends. For example, take a look at this area. This area is this one. It looks like the water surface elevation is discontinued, but this is exactly because we have chosen the horizontal rendering mode, which shows you water surface elevation distributed flat over this 2D cell that we have over here. This is a steep area, and we also have very large cells as well. Okay, so now there is another option, which is called sloping cell corners plus face centers. So essentially this, in addition to cell corners, this option adds face centers points to interpolation. So essentially it's adding more points for interpolation to make the results a little bit more, to make the visualization more accurate than the sloping using cell corners itself. So again, I'm gonna close this, but have this and minimize it and change to sloping cell corners plus face centers and click apply. It should be very, very similar to sloping. There will be some differences, so I'm going to switch back to sloping and take a look at this area. You'll be able to see some differences, especially in this area. So clearly, when we um, switch from sloping only using cell corners to sloping using cell corners and face centers, this area, now it's going to be inundated and we have some depth of water in this area. Okay. Um, so the advantage of this method is that it adds more points in the interpolation. And now the other thing that I want to talk about, you have two options over here. You can use the depth weighted phases, which is called precip mode. What does that mean? It means that um, the interpolate, instead of using a normal interpolation, the interpolation is going to be weighted, and the areas that have higher depth are going to get higher weights, okay, in the interpolation. So it's going to look more realistic essentially. So when you check this on and then click apply, you'll see that again, now the areas are more connected. We don't have an island of water over here. This island of water now is connected to another piece of water over here. And it also differs from the sloping by itself, which is very simplified. Okay. Now let's create our um, water surface elevation map again. This should be very similar to sloping with maybe some differences, some smaller differences. You can see, for example, at station 1400, the water surface elevation is 6259, and over here is 62, about 75. So you can see that the water surface elevation changes, but the overall look of it looks the same. Okay, and there is another mode, and the last one that I want to talk about over here, which is shallow water reduces to horizontal. So what HEC-RAS does over here, for it, first of all, it determines the shallow flooded areas and uses the horizontal to create that flat inundation for those areas. So if I select this and click apply, it's a combination of sloping and flat water surface. Okay, so now if I right click and create a water surface elevation over here, you can see again the, if I go over here, you can 62.60 at station 1400. So the elevations do change and the distribution of water in the cell will change as well. Now, this leads me to the last part of this video, which are the best practices. So you're going to ask the question of which one should I use? And I'm going to tell you that each mode has its place. The sloping method looks cleaner and more natural, but the horizontal um, mode or the horizontal method shows you exactly what the model computed. So again, what's the best choice? I would tell you use all of these options and compare the views to get a full picture of how water is moving in your model. Um, you know, it's important to compare these together because there is a good chance that the topography that you have is different from the topography that I have over here. And there's lots of other factors that impacts how you want to visualize the water surface elevation and how accurate you want the water surface elevations to be, depending on the purpose of the modeling that you are doing. So understanding these visualization tools help you um, tell a more accurate story with your flood models. And this video, the purpose of this video was to tell you, to give you an understanding of the options that you have. All right, thanks for watching and happy modeling.